In this problem, we have two blocks with masses 30 kilogram and 50 kilogram respectively, and they are connected by the weightless, frictionless pulley system. This is important information for later. And they are released from rest, and after they are released from rest, they start moving. And if block A has displaced downwards by 0.4 meter, we need to determine at that point what their speeds are respectively. So as you can see, this setup is similar to one of the previous problems, this one right here. Therefore, we're going to use the conclusions from that problem directly, which is at any given point, this is true, that VA equals to negative 4 times VB, and also AA equals to negative 4 times AB. And the negative sign indicates that they are of opposite direction. So the first thing we want to do is to draw free body diagrams. We need several of them. So for block A, it's subjected to its own weight, which is 30 times 9.81 Newton. And it is subjected to this, in this cable, T1. That is free body diagram. And we also want to draw its kinetic diagram, which is for object A, block A. Its acceleration is in this direction. We cannot know that because we have this hint. It says that block A has displayed downwards. Even if we do not know that information, we can still assume a direction. So for now, I'm going to assume that it is downwards. And actually, I'm going to assume that downward direction is a positive direction. And then times m, and that's its kinetic force. So we can do the same thing for block B. It is subjected to its own weight. And it is subjected to several forces upwards. As you can see, we have the same T1, and this one right here is different, and that's T2. So together, that is 2 times T1 plus T2. However, we can also, and then for block B, its kinetic diagram is that, let's assume the direction is downward again, and that is AB times MA times MB. However, we can also draw the free body diagram of this pulley, let's call it C. So if we draw the free body diagram of the pulley point C, then because itself it's weightless, therefore it doesn't have any weight force acting on it. The only forces acting on it will be the cable, in the green cable, the force is T2, and also T1 here and T2 here. Another T1 here. Now, for this pulley C, there's no kinetic diagram. The reason is because it is actually at equilibrium. Because if you think about it, according to Newton's second law, F equals to ma. So this is total force equals to ma. In this case, because the pulley is weightless, therefore it doesn't have mass either. M equals to 0. So even if it does have acceleration, doesn't matter, the product of ma is still 0. So as a result, if the total force acting on pulley C equals to 0, then the conclusion has to be T2 equals to 2 times T1. T2 and the 2T1 they have to cancel each other out. As a result, this right here simply equals to 4 times t1, which means that our analysis has now reduced to only object A and B. So we did introduce an intermediate step, the pulley C, and that helps us establish this relation. So now we're ready to apply our Newton's second law, the equation of motion, to both of our two blocks. So for block A, resultant force, this is downwards is considered positive now, equals to 30 times 9.81 minus T1, and that equals to the kinetic force, which is the mass 30 times AA. For block B, also downwards is positive, and that equals to 50 times 9.81 minus 41, and that is from the free body diagram, and then from the kinetic diagram, this equals to AB and B, which is 50 times AB. So as you can see, now we have two equations, equation 1, equation 2, but we have three unknowns. We have T1, AA, and AB. So with only two equations but three unknowns, we won't be able to solve all three unknowns. However, there's one more relation that we got from the previous problem, is this one right here. This is our third equation. So now with three equations, we can solve all three unknowns. So we solve three linear equations simultaneously, and we will be able to get the result that AA equals to positive 5.183 meter per second squared. Positive, that's downward motion. AB is 1/4 of AA in magnitude, so negative 1.296 meter per second squared. That is upward motion. T1, we really do not need to know what it is, so we can just leave it like that. However, in this problem, we need to find the speeds. So we have found acceleration, but now we need to find speed. So for that, recognize that AA and AB are both constants. The reason you know they are both constants is because our previous analysis applies to any time. So our previous analysis will not change with time. So AA and AB are both constants. Therefore, for block A, we can apply this equation, that its velocity VA squared equals to its initial velocity squared plus 2 times constant AA, and then basically delta SA, which is 0.4 meter. So from here, this is 0.4 meter, this is 5.183 times 2, this is 0. So from here we can solve for VA. So VA squared is 4.146, and VA equals to 2.04 meter per second. Again, that's going to be downwards, and VB is going to be 1/4 of that, therefore negative, also negative meter per second. Negative sign indicates that it's upwards.